During the COVID pandemic, you've probably seen your government taking different strategies to keep the number of hospitalizations at bay. Behind the politics, models were predicting the effectiveness of these measures. These models are not rocket science, and simple versions can actually be done on a normal computer with free modeling software like R. We model the change in the size of 3 groups of people: healthy or susceptible individuals, infected individuals, and recovered individuals. Susceptible individuals become infected from virus particles released by infected individuals. Infected individuals either recover from the virus or they die. Susceptible individuals can also become recovered individuals straight away by being vaccinated. An important number that is often reported for the coronavirus is the reproduction number. It tells us, on average, how many susceptible persons get infected by one infected individual. Without any measures, the reproduction number for the coronavirus is between 2 and 4 people. Now we are going to simulate how these 3 groups change over time. We model the change in R with the DSolve package. For the initial state, we assume that there are 17.5 million people, like in the Netherlands, and that the outbreak starts with 1 infected person. We try to take realistic parameters, so we choose the infection rate parameter so that the reproduction number is between 2 and 4 at the start of the outbreak. We don't look at vaccination for now, and we assume that people are infectious for 10 days, and we take a mortality of 1% of all the newly infected people. To model the spread of the virus, we write a function, in which we calculate the rate expressions and the mass balance equations. Then we list what we want in our function output, and we run the model for 200 days, and we plot the results. We see that at the start of the outbreak, the reproduction number is between 2 and 4, like in reality. We also see that everyone is recovered from the virus after about 200 days. But this resulted in more than 15,000 deaths and over 4 million infected people at one point in time. This would be a situation that is definitely not manageable for our hospitals.